Today we will be working with multiple step exponent problems. So really you can do these in any order, but I like to keep them in a certain order to make the problems easier and pretty much the same even when the problems change, at least the steps are staying the same. So the first one I like to start off with is the power to a power rule, which you learned in some previous lessons. And for this one, don't forget you'll be multiplying the exponents. The second one I like to do is the multiplication of like bases. So if you recall, when you multiply like bases, you're going to add the exponents. And remember, when you're multiplying, it's a shortcut for adding, so that makes sense that they will go together. And if you are noticing, this is kind of starting to follow our order of operations. We always try to get rid of parentheses first, and if you have a power to a power, you will have parentheses. And then adding would come next. The next one I like to do is the division. So dividing like bases. And if you recall, you're going to subtract. And again, this makes sense because division is a shortcut for subtraction. So it makes sense that they will go together. Dividing and subtracting will go together. And then once I've looked for all of these in this order, the last thing I'm going to look for are any negative exponents or zero exponents. If I have any of those left over at this point, I'm going to clear them out. Remember, if you have a negative, like b to the negative 2, that would equal 1 over b squared. So it would move it to the denominator. Or if you had 1 over c to the negative third, since it's in the bottom already, it would move to the opposite direction. So it just changes places within the number. And anything to the 0 power is always equal to 1. So that whole term would change to 1 if you had any 0 exponents left over. So let's take a look at our first problem, and we'll use this as a reference every time. So the first thing I'm going to check for is a power to a power in number 1, and that means I would see an exponent out here of the parenthesis, and I don't, so I don't have a power to a power. Next, I want to check for multiplying like bases. I am multiplying here. That's what this parenthesis next to this parenthesis means, with nothing in between. If I had a plus sign, that means they'd be added, or a subtraction sign or division sign, that means these two things would be doing those operations. But if you see parentheses right next to each other, it means that they are being multiplied. So that's my first thing I'm going to do, is get all the like bases together. Now negative 2 and 6 aren't like bases, but they are just regular old numbers that we've always learned we can multiply together. Next we have the d's. I'm going to get them together, and once you get used to this, you don't have to always rearrange them, but since multiplication is commutative, that can help me. And then I'm going to put the e's next to each other. Okay, so negative 2 times 6, just like always, they are not exponents, they're just regular old numbers, just like you've been dealing with since you first learned multiplication, and then with the negatives in 7th grade. So that equals negative 12. Now, the d's I want to put together. This d has an exponent of 3. This d doesn't have one showing. If you recall, anytime you don't have one showing, it's usually almost always a 1. So there's one d and there's one exponent that I didn't have to write. So now we're going to add those together, and I get d to the 4th. Next, I have my e's. I'm going to add their exponents, and I get e to the negative 3rd. I check for division of like bases next. My whole goal is to get it down to every letter showing once, or every number showing once, not having multiples of anything. There's no division in the problem, but I do have a negative exponent showing. The negative exponent is attached to the base of e, and it's in the numerator right now. If you don't see a denominator, it's always in the numerator. So it's going to move down. You notice I didn't circle these two, so they do not move. So my answer will be negative 12d to the fourth remains where it was in the numerator. And e moves down and the exponent becomes positive. You always want your final answer to have positive exponents. Negative numbers are okay. Negative exponents are not. So my final answer is negative 12d to the fourth, all of that over e to the third. For my second problem, let's go back and start from the top. Do I see a power to a power? In this one I do. I have an exponent outside of the parentheses, so I definitely want to take care of him first. And remember, we're multiplying to do that. So I'm going to end up with y to the negative 18th, and this means multiplication, so times y to the 21st. It's kind of obvious, but just go down the list to get used to it and get in your muscle memory. I have multiplication of like bases. Y's are the same. They're being multiplied, so I'm going to add the exponents. And I get y to the third. I don't have division. I don't have any negative zero exponents, so my final answer is y to the third. Let's go on to problem number 3. Power to a power. I definitely have an exponent outside this parenthesis. So when I have multiple parentheses, by the way, I kind of try to think of them as one problem apiece. So I deal with this one first, and then I move on to this one. So I definitely have an exponent outside, and it is applying to all things inside. So even though I'm not seeing an exponent on 2, remember there's always a 1 implied on any base you have that you do not see an exponent written. And this 3 is applying to all the parts inside. It's kind of like distributive property. So I'm distributing 3 to all the exponents inside, and I get 2 to the third, negative third, excuse me, and m to the negative fifth. Okay, times, let's see, I have another exponent, and it applies to all things inside. So I'm going to distribute the exponent to all the other exponents or powers inside. I get m to the 16th, n to the 20th. Okay? Do I have multiplication of like bases? Yes, I do. There's all multiplication in here. I see a multiplication symbol here. If I don't see one between the terms, I'm assuming they're glued together with multiplication, between the bases, excuse me. So if you don't see a multiplication symbol between the bases, they are still being multiplied. So it looks like my m's are next to each other. I don't have to rearrange them unless I absolutely want to. So I'm going to go ahead and add those exponents together. I get 2 to the negative third, m, negative 15 plus 16, and n to the 20th. And I don't have to write the 1 because remember, it's understood. I like to think of it as Harry Potter and his invisibility cloak. I see the 1 to help me sometimes, like up here he had to come out so I could see him, but then he went back under the invisibility cloak here for the final answer. Well, division, excuse me, I do not have division of like bases, but I do have a negative exponent remaining, so I want to take care of him. Negative 3 is attached to the base in front of him, never behind. And again, recall, if you don't see a denominator, it's assumed to be in the numerator, and there's an understood 1 there. So this is going to move down. Remember, it always moves to the opposite position. So now I did not circle these, so they remain in the numerator. And in the denominator is 2 to the positive third. Now all the exponents are positive, but if you know what the numerical base's value is, and it's not, like 50,000, go ahead and simplify it. So I'm going to say that this is n to the 20th over 8 as my final answer. You used step number 1, step number 2, and number 4. Let's look at number 4. Do I have a power to a power? Well, I don't have any parentheses, and I don't see an exponent outside like I did over in number 3, so I'm going to skip power to a power. Do I have multiplication? Yes. Are they like bases? No. No. So I don't have the multiplication of like bases step. But am I dividing? Yes. Do I have like bases? Yes, they are not over each other, and that's okay. Just pay attention to that. So I'm going to go ahead and do that one. Step number 3 first. If you would like to rearrange it, you can to help make your life easier, but there's really no need to. So what I mean is this: if you want to flip them so that the x's are over each other and the y's are over each other, you may do so. But again, you don't have to. It'll still work. When I'm dividing like bases, I'm subtracting the exponents. And we always subtract in the numerator. So I subtract 4 minus -1. And I like to cross them out so I don't forget I've used him. And then move to the next one. -8 minus, always put the minus first. Don't just look at what you're given, because this negative sign from number 1 is not the subtraction symbol. That means the number is negative. I actually had to do the subtracting. -8 minus 6. I'm going to cross him out. So what's remaining is x to the 5th, y to the -14th, 14th, and it's all in the numerator. When you're doing subtraction of like bases, it takes place in the numerator, and it stays in the numerator until any other steps happen. Looking at this, I do have a negative exponent showing. I haven't had any zeros pop up yet, but if I did, I'd take care of that at this point. -14, and it's attached to y. It's in the numerator because I don't see a denominator in the problem. Like here I saw the denominator, here I do not. So it's going to move down to make him positive. And my final answer is x to the 5th over y to the positive 14th. Moving on to problem number 5. Let's check for power to a power. I definitely have parentheses, and I see a power or an exponent outside it. Remember, we're going to be multiplying the 5, this power, to all other powers inside. So it applies to every base inside, including the denominator's base, or bases. So at this point, I have a to the 10th, b to the -20th, over b to the 10th. And remember, you could do these in any order. If you do get them out of order, it'll be fine as long as you do the property right. But this way, it just helps make it a little bit more consistent and a process to follow, so it doesn't seem like you're just jumping all over the place. All right, I like to check for multiplication of like bases next. I do have multiplication, but they are not like bases. So I'm going to move on to dividing like bases. I do have division, and I do have like bases. So I'm going to subtract the exponents. And remember, subtract whatever that exponent is. If that had said -10, I would have said minus -10. I like to cross them out just to remember that everything is in the numerator. And I get to the -30th. Okay. I do have my last one too, a negative exponent. Usually that's the one that's going to show up. Not always 0 shows up, but again, if it did, the whole thing would just change to 1. So my negative exponent on this one is on the b only. It's going to move down because it's in the numerator. So the a I did not circle, so I write a to the 10th over b to the 30th. Remember, moving it changes the sign. You cross that line, you change the sign. My final answer is a to the 10th, b to the 30th, over b to the 30th. For my last problem, it has a lot of steps in it, so we're going to again go through all of them. And let's go ahead and get started. So we have power to a power. I definitely see a power of -2, and it's whatever is in that parenthesis. The 15 is not in the parenthesis, so I don't want to include it. Don't forget, when you do not see an exponent, it's always implied to be a 1. So I'm going to put a 1 on t. I'm taking it out of its invisibility cloak. And now I'm going to distribute the -2 to what's in the parenthesis only. Let's go ahead and rewrite what I have. 15, r to the -6, t to the -2nd. I can drop the parentheses since I have the purpose of them was for the -2. Nothing else has changed at this point. So I'm going to rewrite it. So I have this fraction or division problem times r to the 4th, t to the 5th. Okay? When you have a fraction problem, I do have multiplication in here, but they're in 2 different fractions. Because again, remember, you can think of this as one fraction. So you could do it, or you could think of it, since this division line, it kind of groups all this together. So you might want to work this down first. So I'm going to skip the multiplication and go to division. Kind of like an order of operations where you do all the things inside the parentheses and then you end up having to go back to the start after you get rid of the parentheses. Kind of the same idea. So I have R, T, and T. So I'm definitely going to be subtracting the T's. So -7, since that was the exponent on 7. Now with the numbers, these are just plain old numbers. Like in a previous problem, I had numbers being multiplied. Well, this just means 15 divided by 10, and it's just a reducing of a fraction. And I know both of these are multiples of 5, so if I take a 5 out of each of them, I am left with my remaining fraction. Again, these are not exponents. These are just regular fractions like you've always dealt with in reducing them. So at this point, my fraction is 3/2. The t is not in the denominator anymore. I have r to the -6 in the numerator, along with the t to the -9th from when I subtracted. So that's my first fraction now, times r to the 4th, t to the 5th. And again, remember, if you don't see a denominator, it's always implied to be over 1. Now, I do have negative exponents, but I still have like bases. I still have r's and t's. And if you look, they're all in the numerator at this point, which means they're all being multiplied. That's the multiplication symbol. There's nothing in between like we talked about, so it's implied to being multiplied. So I'm going to go back and use number 2. And again, we could have done that first, after we did power to a power, and then gone with division. And like I said, it doesn't really matter as long as you do the properties correctly. The order can be mixed up a little bit. So the r's here, I'm going to go ahead and do some side work since this is getting a little messy. I've got r to the -6 times r to the 4th, which means I'm going to end up with r to the -2nd. I'm just going to put a squiggle here to let me know it's some side work. And then I've got t to the -9th times t to the 5th, which is going to result in t to the -4th. So these are the ones that are going to end up in the problem after I combine the r and t bases. And if you see, they're all in the numerator, so they're going to remain in the numerator with the 3. So r to the -3r to the -2nd, t to the -4th. And in the denominator, this is 2 times 1, so just 2. My last step is to check for negative or 0 exponents. Definitely have negative exponents. R's negative exponent is -2. Remember, 3 has got an implied 1, so that's not negative. It's always the base right before it. It's going to move down. T's got a negative exponent of -4, so it's going to move down. I didn't circle the 3, so it's going to remain exactly where it is. And instead, the r is going to move down and the exponent's going to become positive, and the t is going to move down and the exponent's going to become positive, and the 2 also remains exactly where it was at. It did not move either. I like to circle them to help me remember what I'm moving and what I'm not moving. So from this problem up top, I actually ended up using every single step over here to get my final answer.